Everyone, this is review number 5, 1.2 functions. We are going to look at functions and we're going to begin with looking at domain and range. So the domain, as a reminder, is the values of the independent variable. So it's your input or your x values. The range is the value of your dependent variable or your y values. So looking at this function, f of x equals the square root of x divided by x subtract 2. We are going to list what that domain is. So the domain, the first thing we have to do is we have to look at the numerator. In the numerator, there is a square root, and we know that underneath that square root, we can only have positive values. So in the numerator, x is going to be greater than or equal to 0. Now the denominator cannot be equal to 0 or our fraction is undefined. So 2 subtract 2 would give me 0 in the denominator. Therefore, x cannot equal 2. So let's write the domain first, and then we will look at the graph for the range. So we know that the domain can only be 0, positive numbers, but I cannot include the value 2. So how we write this in interval notation, and I'm going to write it below because I haven't gotten great with this pen yet. But so we are going to, this should be a bracket, and we're going to start with 0, and we're going to go to 2. And then, I don't love that bracket. Let me erase it. Let's try again. Sorry guys, still getting used to all of this. So this is a bracket, and it goes from 0 to 2, and then U stands for union, so we're going to include, and then we're going to pick back up at 2 again. This is a parenthesis, and we're going to go to infinity. So that is what the domain looks like. Now, if I bring this graph over for you to see, let's try it. So here's what the graph looks like. You can see that the domain is everything starting at 0 and moving to the right, except for we're not going to include x equals 2. The range, you can see it starts down at negative infinity, and it moves all the way up to positive infinity, to go from negative infinity to infinity. Here's a reminder on function notation and what a function is. Remember, a function is a rule that assigns for every element in the domain, there is exactly one unique element in the range. So for every input, there's exactly one output. We have two equations, y equals 2x plus 1, and function notation just means instead of writing y equals, we can write f of x equals. If we are looking for find y when x is equal to 3, all we simply do is everywhere that we see x, we plug in a 3, and f of 3 then is equal to 7. In this example, we see mapping diagrams that represent a function, and one does not represent a function. So looking at Taco Bell, for every input, we have 12 items. We get exactly one cost of $16. 20 items gives us the cost of $20. Now, if we look at P.F. Chang's, you can see that 4 items on the menu could cost us $60, or 4 items on the menu could cost us $75. Because 4 is mapped to two different numbers, P of Chang's in this example is not a function. One way, if you think about why this ended up not being a function, is P of Chang accepts tips. So if I buy 4 of the same items, one person may pay $60, but another person may pay $75. So that may be one reason why Taco Bell ended up being a function and P of Chang's did not. All right, looking at using the vertical line test, we can use the vertical line test to determine if a graph is a function. If any vertical line intersects a graph at more than one point, then the graph is not a function. Example 2a. We drew the vertical line and we noticed that it only intersected the function in one spot. So example 2a is yes, it is a function. Looking at example 2b, we draw a vertical line. It intersects the graph in two places. So example 2b is no, it is not a function. Example 3, we're going to evaluate this function, which is called a piecewise function. There are two pieces. The first piece is 2x plus 5. We use that piece when x is less than or equal to 0. The second piece is 2 subtract x squared, and we use that piece when x is greater than 0. So looking at example 3a, you'll notice that f of -2 is a piece it's going to go into the first piece because -2 is less than or equal to 0. We take 2x plus 5, and everywhere we see an x, we plug in the -2 to find f of -2. So this will be 2 times -2 plus 5, and this equals -4 plus 5, which is equal to 1. Looking at B, f of 0. Now because of the equal to line here, we're going to put it into the first piece. So 2 times 0 plus 5 is equal to 0 plus 5, which is equal to 5. Find f of 1. 1 is greater than 0, so we'll use the second piece, 2 subtract x squared. In place of x squared, we'll plug in 1, which goes in for x. 2 subtract 1 squared is 1, and that is going to equal 1. Example 4, we are going to take the function f of 3x subtract 1 and find what f of 5 is equal to. The very first thing we want to do is take 3x subtract 1 and put it equal to 5. And we're going to go ahead and figure out what x is equal to. So just a two-step equation, and you can see that x is going to be equal to 2. Now what we're going to do is take this function, and we found that f of 3x minus 1, when we're looking for f of 5, is equal to 2. So now we can find what f of 2 is equal to. So f of 2 is equal to, in place of x, we're going to plug in 2. So I have 2 squared plus 2 plus 1. 4 plus 2 plus 1. And our final answer, 6 plus 1 is equal to 7. So f of 3x subtract 1 is equal to 7 when I'm finding what f of 5 is. In calculus, you are going to look at piecewise graphs and graphs that have continuity and graphs that have discontinuity. So very quickly, it's important you understand the definition of both. So continuity is simply a graph that is continuous. So if you were to trace the function with your pen or pencil, you would not lift it up at all. All of these graphs below are discontinuous. So these are types of discontinuity. There is the removable hole. As I'm going along my graph, there's a hole in the graph. So I have to lift my pen and then continue on. So that's called a removable hole. Graph number 2 is called a jump. So you are going along and then you jump up to this other piece. Notice graph number 2 is still a function. It still passes the vertical line test. When I draw a vertical line right here, you can see that this is included and this is not. So it still passes the vertical line test. And graph number 3 is considered infinite discontinuity because we have this jump here at 0 where the graph is undefined. Example number 6, we're going to determine if the function is continuous, or if it's not continuous, what type of discontinuity does it have? So one of the easiest ways to do this is to go ahead and graph it. Just reminding you how to graph a piecewise. We have 2 pieces. We have a line and we have a parabola. So let's go ahead and look at graphing those. Looking at the linear piece, negative x over 2 subtract 1, I picked values where x was less than or equal to 2. So I picked 2, 0, and negative 2. 2, I plugged it in for x. I got negative 2 divided by 2 is negative 1. Subtract 1 is negative 2. So if I graph that, it's right 2 and down 2. And then 0, negative 1. When I plug in 0, I got negative 1. And I picked even numbers since I was dividing by 2. And then when I plugged in negative 2, I got 0. And I believe I can trace this with a line. Let's try it. So this is going to be that piece of the graph. Now looking at the quadratic piece, so maybe I'll use green. And now we're going to graph this part of the graph. Looking at the quadratic piece, you can see that I set up a table again. Now it's really important, even though the quadratic piece is x is greater than 2, you still start with 2 in your table because that is where the graph is breaking. And at that 2, you're going to have an open circle. So when I took 2 and squared it, made it negative, so negative 4, plus 2 times 2, which is 4, subtract 2, I got negative 2. Now this 2 negative 2 is going to be an open circle at this same place that the other graph was. And so there's not going to be a break in the graph. If I take 3 and plug it in, remember that you're going to, here's just a Algebra 2 reminder, is you're going to take 3 and square it and then make it negative. So 3 squared is 9, which is negative 9, plus 2 times 3 is 6, and then subtract 2. And so that's negative 11 plus 6, which is negative 5. So this is going to be right 3 and down 5. And what's going to happen is you're going to have this piece of this parabola, which looks something like that, sort of, kind of. I know, not the best. All right, so this graph happens to be continuous at x equals 2. So x equals 2 again is if I were to draw this vertical line here, what's happening to the graph right here. At that point, because the two pieces actually connect, that graph is going to be continuous at that point. So the multiple choice answer is C. Example 7, this is going to be the most important problem of this section. We are going to see this same problem all year long because it's very closely tied to calculus. So looking at example 7, if we have f of x is equal to x squared minus 4x plus 7, we are going to find f of x plus h minus f of x over h. So you start with f of x plus h, and how that works is you come over to function f of x, and everywhere you see an x, you're going to put in x plus h. So let's do that. So now I have x plus h squared, subtract 4 times x plus h plus 7. And now it's subtract f of x. So now we are subtracting f of x. So how we're going to subtract f of x, and that wasn't a highlighter, so let's just erase that. All right, is we're going to subtract f of x, which is that function. So it's subtract, and then you are going to subtract the whole thing, which means you need parentheses. And then you subtract x squared, subtract 4x plus 7. Now we're going to put that whole top part over h. So we're going to divide that by h. Now we're going to simplify everything. So x plus h, you have 2 of those. So you have x plus h times x plus h. Just a reminder, first times first is first. Outside times outside, inside times inside, and last times last. You can see that this is like a dude here. Hi, that's his smiley face. There's his eyes. You see all that? All right, so x squared, and then xh and xh is 2xh, and then last times last is h squared. And then take the subtract 4 and distribute it. So negative 4x and negative 4h plus 7. And then you're going to have subtract x squared plus 4x and subtract 7 all over h. And this is the number one mistake I see, is this negative has to get distributed through the parentheses. And so if you forgot the parentheses, then that's going to be a big problem. So these parentheses right here were really, really important so that we would distribute that negative through the entire thing. All right, let's simplify. So now a whole bunch of stuff is going to cancel. Let me use red. So the negative x squared and the x squared cancel. The 7 and the negative 7 cancel. The 4x and the negative 4x cancel. So now 2xh plus h squared, subtract 4h over h is what I have. But do you notice you can factor an h out of the numerator? So the h is going to factor out of the numerator, leaving me this. And now you have h over h, which can cancel. And final answer, you can't cancel the h here until you factor it out. So now my final answer is 2x plus h subtract 4. This is a really, really important problem. So if you were a little shaky on it, rewind and watch example 7 again. Thanks, you guys. That's it for today.